Yes, they can hear you. They'll hear you too. Okay? All right. Factoring quadratic equations. All right? So I'd like you to take a look at what I call these prerequisite reviews. From grade 10, you should have been able to factor these things. Now, do you actually remember factoring this? Do you remember how? Do you remember these algebra tiles? Did they help you out? Do you guys remember doing that kind of stuff? Yeah, you didn't like that stuff? No. Okay, so let's just forget them, shall we? Okay. So help me out, somebody. Do you remember how to factor this trinomial?
Wait, is this review?
This is review right now, yes. Okay. Good. The idea is you have two numbers that add to 4, and those same two numbers have to multiply to that constant term, 3. So you got to play a little game with yourself and think, what times what gives you 3, and that same 2 combination gives you 4? 1 and 3, good. So 1 and 3, and 1 plus 3 gives you 4. So therefore, the factored form, you just break up the x squared into x and x, and you get x plus 1, and then x plus 3. Done. Okay? By the way, if you ever want to check to make sure you're correct, you can always check by expanding. And I'm just going to show you quickly right now. If I were to take that factored form now and take x times x, you get... help. Okay, x squared. X times 3 gives us 3x. 1 times x gives you x. And then 1 times 3 gives you 3. Don't forget, if you simplify, you'll get this. And that's the same as above, so you're good. Okay? All right, you try B. It's the same idea. Okay? So for B, if you're curious, you're looking for two numbers that multiply to what? Can someone help me out? What number? Oh no, what numbers are multiplied to first of all? 8, yeah. And those same two numbers add to negative 6. Negative 6. And then Rochelle, you said the answer would be what combination? 2 and 4. 2 and 4. But 2 and 4 give me positive 6. I want negative 6. Yeah. Sophia says negative 2. Yeah, let's make it negative 2, negative 4. Negative 2, negative 4. Because negative 2 times negative 4 is positive 8. Negative 2 plus negative 4 is negative 6. That's good. So here we go. X minus 2, x minus 4. We're done. Okay? All right. Let's look at C. C. For C, I have this question. Now notice in front of the x squared term is a negative 2. Ew, yucky. What should you always do first before you do what I just did in the previous types of factoring? Factor out what we call the greatest common factor, the GCF, okay? Always do that, and I'll say first. So in this case, what would be my greatest common factor? Yeah, negative 2, good. So I'll factor out the negative 2 first. We'll have x squared that's left over. And then 16 divided by negative 2 is? Negative 8, thank you, Sophia. And then negative 32 divided by negative 2 is positive 16. Okay? And then now once you get this trinomial, we want to do the same thing as before. Think about now two numbers that multiply to 16, and those same two numbers add to negative 8. And what do we have? Negative 4 and negative 4. Right, they're the same thing. So negative 2 bracket x minus 4 times x minus 4. Or if you want to be mathematically sophisticated, how do I write those two things a little bit nicer? I'll say this is negative 2 bracket x minus 4. And if it's the same thing, we'll just say it's squared. Okay?
Can that recording catch you speaking loudly?
Yeah, the recording right now will catch me speaking and writing too. Okay? That doesn't mean you should be studying your other material, by the way.
I'm not.
Okay, next one here. D. Okay, this is where it gets kind of tricky. This is a different type now, okay? This is the type where I'm going to say to you, if you're not too sure how to do this one, look at the review sheet I just handed out, okay? That I just handed out. This one. The one that says factor 6x squared plus 7x minus 20. Okay, this is a different one. Now, from last year, do you guys remember which method you learned from your grade 10 teachers? Was it guess and check? Was it decomposition? Was it choose method? Bottoms up, yeah, that's the choose method thing. That's number 3. Okay, 1 vote for number 3. What about the rest of you guys? Decomposition? 1 vote for number 2. It's a tie right now. Who wants to break the tie? Which one? Bottoms up too? Decomposition? No, you already voted. Do you guys remember what you did? Which method? Don't know? Don't know, Danny? Bottoms up? Okay. Bottoms up is the choose method.
Oh, I only got one.
You don't like that one? Oh. Okay, stop. This is where it's hard for me as a math teacher. Okay, I will show you both ways. Okay, but then in the end, I have one I prefer, and I'm going to use that one. Okay, but I'll show you both ways for at least D. Okay, all right. Both bottoms up or decomposition starts the same. Okay, so let's write this down. I want you to find two numbers that multiply 2, and it's not just the 3 this time. It's 2 times the 3. Okay, so two numbers which multiply to actually 6. And those same two numbers have to add to the middle term, which is 7. Okay, so both methods, we still do this. Yes, Andrea?
How can you tell which methods you need to use?
Ah, okay. Andrea, if you look at the previous ones from A and B, you'll see the number in front of the x squared is just a 1. Okay? Now for part C, you're thinking, well, Mr. Lee, there's a negative 2 there. You're right, but you see how I factored out that negative 2? So then inside the bracket, that's still an A value, or the value in front of the x squared being 1.
Oh, that one.
All these other ones over here, then, the A value is not equal to 1, and therefore you need to use this different method. Okay? All right, what's the combination here? Two numbers that multiply to 6 and add to 7. Help. 6 and 1. Okay, 6 and 1, 6 and 1. Okay, here's where they differ. So let me show you which one first. Decomposition? Okay, I'll do decomposition first. I'm going to do this on a different piece of paper or different handout. Okay, so 2x squared plus 7x plus 3. Okay. So we found the two numbers, right? They were 6 and 1. Okay. This is the decomposition method. Okay, if you don't like this, then just watch for a sec. If you do like this, you better write this down. And if you don't like this, you want to write down, go ahead. Decomposition says the following. Let's decompose. Let's break up the middle term. Okay? And I'm going to break it up this way, using the numbers 6 and 1. Notice that the middle term can be written as 6x plus 1x. Agree? Because that's equal to 7. Then with decomposition, I'll say look at the first two terms, and I want you to factor by what I call grouping. Okay, so look at these first two terms. Okay, so take your hand and like ignore this stuff. Pretend it's not there. Okay. Looking at the first two terms, is there something that's common between the first terms that I can factor out? 2 and what else? X, 2x, good. I'm going to factor out the 2x from the first two terms. Now, what's 2x squared divided by 2x? X, good. What is 6x divided by 2x? 3, good. Okay. Now, I want you to also factor by grouping with the other two terms that are remaining. So now take your hand and hide the first part. It's gone. And take a look at this part. And I'm saying to you, what's common between 1x plus 3? Just 1. Okay, so I'm going to just factor out the 1 then, plus 1. And what's left over? Well, x plus 3. Now, be careful. When you're doing decomposition, the stuff in the bracket should always be the same. If they're not the same, you screwed up somewhere. Okay? Now what I'm saying to you is we've got one term on the left, the blue one. We've got one term on the right, which is the black one. Is there something common between these two terms? X plus 3. So then we'll factor out the x plus 3. And then what's left over? Well, from the blue stuff, what's left over is the 2x. From the black stuff, what's left over is the 1. And there you go. You factored this one by decomposition. Okay? That's decomposition. Okay? Now, I'll also show you choose method. And I believe that these two methods are the best. I have a preference, but you might like one or the other. Doesn't matter. Just know how to do it. Okay? Let's do choose method now. Okay, so if you want to write down choose method, please do. Choose method. By the way, do you know the story behind where this name came from? Asian person? Yeah, but do you know what happened? He was an actual student, not of mine, but of some other math teacher from the 18th century. And the math teacher was doing his work and showing this stuff like decomposition, and the student in the back says, Mr. blah, 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 I have this better way, and he showed it. It worked. So the teacher said, oh, let's just call it the choose method. Then you'll have fame and glory. And that's how it came about. Okay? So if you come up with some good story or good method of doing things, I will name it after you. I don't know. The Stoyanovich method. The foo theory. Right? Sorry, Stoyanovich. Okay? I will give you glory if you want. But it has to be right. Don't give me any like bad math stuff. That'll just make you look bad. Okay, choose method. Remember, choose method is the same, okay, right? We found the two numbers, and they were 6 and 1. Okay, now choose method is very similar to the previous one we did. Here's what you do, okay? Sorry, let me write down the question again first. Okay, here's what you do. With choose method, we found those two numbers, and this is what you do. You put an x plus a 6 and x plus a 1. So this is very similar to what we did before, okay? The only difference now after you've done this is now you need to do the following. You need to divide, okay, divide each term by the a value. What's the a value of my original question here? It's 2. So this is the extra step you need to do with choose method, okay? Take the 6, divide by 2. Take the 1, divide by 2, okay? Then your next step is to simplify the fraction. Okay, and you'll always get a fraction, so you'll have to simplify it. Help me out, somebody. First one, 6 divided by 2. Okay, can we simplify the other one there? Okay, I don't want decimals, so let's just keep it as a fraction. Okay, and then this is where some of you call this bottoms up, because now with your remaining fractions, okay, you can take the denominator and stick it up there right next to the x. So in this case, your final answer is x plus 3, 2x plus 1. That's choose method. Look, the answers are the same. Okay? All right, ladies and gentlemen, which one do you like better? Can I just take a poll? Who likes chew? Who likes decomposition? What do the rest of you like? Okay. Ladies and gentlemen, I don't care which way you use it, just do it. Okay? So, can I ask you now to try, please, and do the next questions? So, can you try part E and get the solution for me, please? And then I'll ask you to try part F as well. Okay? So, go ahead and try part E. If you're wanting to start, we'll start together. It's two numbers that multiply to, don't forget it's 2 times -5, which is -10, and those same two numbers add to -9. Okay? Go for it, please. Okay, I'll do this one by chew. I'll do the next one by decomposition. Okay, so in this case, the combination that works is, how about 10 and -1? Oh, yes, it's -1. Oh, sorry, it's -10 and 1. Yes, because you want -9. So by choose method, I'll say x minus 10, x plus 1. And then the extra thing you do for choose method is you make sure you divide each of those numbers by the a value, which is 2. Then I'm going to ask you to simplify, so this becomes x minus 5. And then bottoms up with this part, that's 2x plus 1. You are done. Okay.
I have a question. When we're doing questions like these, you're always going to have a 2x plus 1.
No, it's just so happened to be that way. Okay. Now let's do F. By the way, if some of you are doing this, two numbers that multiply to 60 times 60, I'm saying, ouch, that's not so great. What should I do first in all these questions? Simplify. See if you can factor out the greatest common factor first. Okay. Remember, when you do big stuff or big numbers, think, Mr. Lee is trying to hurt you? No, he's trying to make sure you can do things a little bit simpler. what is the greatest common factor between all those terms? 10. I'll actually go even further and I'll factor out the negative because I don't want to deal with negatives afterwards. Okay, so I'll actually factor out negative 10. And then you get 6x squared plus 5x minus 6. Nice. Okay. Now, it's time to factor. So two numbers now that multiply to 6 times negative 6, which would be negative 36. Those same two numbers now add up to 5. So I'll let you think about that. And can someone shout out the right combination once they have it?
9 times negative 4.
9 and negative 4 gives you negative 36, correct. 9 plus negative 4 gives us 5, correct. Okay. Now this time I'll do it by decomposition. And I'm going to ask you to keep the 10 outside the bracket. And then now instead of having the 5x, I'm going to replace that with 9x minus 4x. All right. Okay. How about I give you a few seconds to try this out, okay, and then we'll come back. This one yet? So by decomposition, once again, I'm going to ask you to look at the first two terms and tell me what's common amongst the first two terms.
Yes.
Okay, good, 3x. So what's left over? I think a 2x plus 3. Okay, now look at the next two terms, the negative 4x minus 6. What can I factor out from there? Negative 2. And what's left over? 2x plus 3. Hey, you see how they're the same thing? Good news, good news. So then I will factor out the 2x plus 3, and this is what you're left over with. The 3x minus 2. And this is your final answer. Okay?
Is there negative 10 on the other one?
That negative 10 just keeps coming from that negative 10 we factored out from the beginning. Okay? All right, last one. Remember, this is all supposed to be review. If this is not review for you, make sure you learn this, okay? If you want to come to my grade 10 class, that's period 6. Come by, take a look. We're doing the same thing right now. Okay? Or watch my grade 10 videos if you wanted to. Okay, 4x squared minus 9. This one is totally different. Or is it?
No. It's just plus 0 at the end.
Oh, okay. Well, I mean plus 0 at the end. I wouldn't say that. But if you want to write it in that format, it's 4x squared plus 0x minus 9. Okay. So I guess you could do it like this. Find two numbers that multiply to negative 36. And those same numbers add to 0 and try. That's not so smart, Tenacia says. Okay, so this works, but it might not be the best way. Okay? What's the best way? Can you notice that this is what they call a difference of square? Do you guys remember that stuff? Difference of squares? Do you not learn this in grade 10? A squared minus b squared equals to a plus b, a minus b? No? Yes? Hello? Okay. Any case, if you want to go ahead and do this way with choose method or decomposition, it works. But if you recognize that this is a difference of squares, because you see you have one term that's all squared minus another term that's squared, then you can just write it into this form and you're done. So I'll show you difference of squares really quickly. Can someone tell me if this whole thing here, 4x squared, is a squared, what's the value of a going to be? Yeah. 2x. Good. Not the 4, but 2, right? 2 squared gives you 4. X times x gives you x squared. Good. Now, if the other term here is supposed to be my b, then what's actually the, sorry, b squared, what's actually b? Isabel, you have an answer there?
3?
Yeah, it's 3. The square root of 9 is 3. Okay? So if you've identified a and b, then all you need to do is just stick it into this formula. You've got here the answer 2x plus 3, 2x minus 3. You're done. Okay? Done. And by the way, you would have done the same thing and got the same answer if you did it the previous way using choose method or decomposition. Same thing. Okay? All right. Let's actually start grade 11 stuff now. Okay? Here's the grade 11 stuff. In section 4.1, we learned how to actually solve quadratic equations by using the graphing calculator. Okay? So you did that, punched the buttons, it was all good. When solving quadratic equations, what you actually did was you made that ax squared plus bx plus c, that standard form, equal to 0. Okay? Some quadratics, I'll tell you, you can actually solve or find the solutions very easily by using this method called factoring. Okay? And what we're going to use is something called the zero product property. And that zero product property states that if the product of two real numbers is 0, then one or both must be equal to 0. Now you'll see this term quite a lot, okay, in your textbook. It's called the roots of the quadratic, okay? The roots, another word for it, aka also known as the x-intercepts, okay, which is what we found before, or we also call them the zeros. Roots, x-intercepts, zeros, they all mean the same thing. Why do we do that to you in math? I don't know, but they do, okay? So what I want you to understand is if I ever ask you to solve, I am asking you to find the roots, or I'm asking you to find the x-intercepts, or I'm asking you to find the zeros. It's the same thing, okay? So let's do example number 1 now. This is the actual grade 11 stuff now, okay? Grade 11, here we go. How would you solve this? Solving means make this equal to 0. So can you actually write down equal to 0 next to it? No, don't talk about the formula yet from Germany. I will do that in 2 classes, okay? Shh, keep it a secret. Okay? Shh, secret. Yes, Isabel. Shh, don't tell me.
Tell me. I'm surprised. I'll pay you.
By the way, the secret's also in your textbook. You can read it, but and I'll tell you a way of memorizing that too. Okay, I will give you some presentations, performances. Okay. But anyways, that's next week, not now. Okay, let's get back to this. How would you solve this one? Well, you would have to factor first. Do you remember how to factor x squared plus 4x plus 3? I hope you did, because we just did that right above. What is it equal to? X plus 1 and x plus 3. So you factor, and I'll say like above, so we don't have to do it again. See how nice I am? And then we got x plus 1, x plus 3, like what Sammy said. And this equals to 0. Now, what does this zero property product say then? It says if one of them, or if the product of two real numbers is 0, that means one of them has to be 0. So then you're doing this. Either the x plus 1 must equal to 0, or over here, the x plus 3 equals to 0. Now, can you solve this, Isabel? X equals to what number over here? Minus 1, good. Negative 1. And over here, minus 3, or negative 3. And ladies and gentlemen, there are your 2 answers. Okay? Now, just, yes, Isabel?
I don't understand how you get the x plus 1, x plus 3.
I did that from above here. This idea of factoring. You missed it. I'll show you in a second. Okay, I'll do another one with you. Okay? Now, before I do the next one, part B, can I just show you visually that this is actually correct? How would you have solved this last section? You would have done the following. Okay, you would have graphed out x squared plus 4x plus 3. Right? And you graph. And this is what you get. Where are my answers? Where are the zeros? Here and here. Okay? So, let's see if I can find them for you. Okay, let me zoom in first of all. I'll zoom in just a little bit over here. Okay, let's see if we can actually find the zeros. Can someone actually tell me what they are by looking at this right now? What's this value here going to be?
1.
Not 1, careful. Negative 1. What's this one over here going to be? Look, negative 1, negative 3. Same thing. Okay? Same thing. All right, let's do part B. This has to equal to 0, so let's go ahead and solve. Now, I'm going to do the factoring again for our friend's sake back there. So remember, the idea is 2 numbers that multiply to 8. It's the 8 there. And those same 2 numbers have to add to negative 6, careful, negative 6. And then we try to find the right combination. What times what gives you 8? And the same combination gives you negative 6. Someone said 4 and 2. That's close. Which one's negative? Both are negative? Yeah, that's right. Both are negative. Good. So then what we have now is x minus 4, x minus 2, and that equals to 0. And now go ahead and try to solve. So make each of the brackets equal to 0 and solve. Okay. What do we get at the answers there? X equals to 4. X equals to 2. There you go. You are done. Okay. Pretty much. Yep. Okay. Turn the page. And I guess I have C, D, E, F, G for you to try. And look at this. They're all the same questions as above. So go ahead and just copy down what you got from the first page and then solve. By the way, make sure you put equal to 0 on all of these, please. Equal to 0, equal to 0. Okay? Now, to help you out, instead of flipping back and forth, why don't I do this for you? I will put this on the screen so you can copy them, and then you don't have to flip back and forth. Yes? Okay? So, I want you to copy this. Copy this. Copy this. Copy this. And then copy this other one over here. Okay? And then you can solve it. So go ahead. Please solve, please. So go ahead and copy them, please. I'll stop the recording right now. Okay, let's do D first. What's the answer for D after this? You get x plus 3 equal to 0, and when you solve x equals to negative 3. And then you also want to make 2x plus 1 equals to 0. And if you do that, you get 2x equals to negative 1. And don't freak out if it's a fraction. It's okay. Divide both sides by 2, so x equals to a half. Okay? Now, let me go back to C. C is interesting because, number one, there's this negative 2 in front. Does that affect our answer anyway? Well, think about it. What we have here is we have negative 2 bracket x minus 4 equal to 0, right? So I guess I can make this equal to 0, and you get x equals to 4. If I do the same thing here, I also get 4. Now, do you need to write things twice? No. So that's perfectly fine. Now the question I have for you is, what about this number in front, the negative 2? Well, should I make that equal to 0? If you do, you get this. Does negative 2 equal to 0? No. So guess what? That doesn't work either. So you don't actually have to worry about that negative 2 in front. Okay? Because there's no x value there, it doesn't make a difference. So therefore, for part C, there's only one answer, x equals to 4. Okay? All right, let's do E. Can I just quickly find the answer now? X equals to what for E? This one is 5. What's this one here going to be? What is it going to be? Negative 1/2. Good. Okay. Next one. F. Once again, that negative 10, ignore. It doesn't make a difference. So just solve 2x plus 3 equal to 0. So x equals to, I believe, negative 3 over 2. And this one over here, make 3x minus 2 equal to 0. Solve for x. X equals to 2/3. Okay? And last but not least, how about this one over here, the difference of squares? This becomes, and I'll just give you the answer, negative 3 over 2. And this one becomes, I believe, positive 3 over 2. Okay? Are we okay so far? Do I need to go over anything else? No? Okay. Let's see if we can finish off example number 2, and then I'll stop for today, okay? All right. Example number 2. These are more complicated ones, okay? Now let's do some like grade 11 stuff. Grade 11 type factoring. okay, they'll get trickier and trickier and trickier. So please listen up. Okay, 2A. What I want you to do with all these questions is you should move everything to one side first. The right side should be equal to 0. So can you move the 80 to the left side? So you get 4x squared minus 32x minus 80 equal to 0. Okay. And then I'm going to ask yourself, you should be able to factor this now in those two brackets. But before you do that, what should you be thinking about? Is there something that is common between all three terms? 4. So please factor out the 4. What's left over when you factor out the 4? 4x squared by 4 is x squared. 32 divided by 4 is 8. 80 divided by 4 is 20. Good. And now my suggestion to you is let's see if you can factor the stuff in green here. Because the value of the a, or the coefficient in front of the x squared term is a 1, we just use the regular method of factoring. So two numbers that multiply to negative 20, those same two numbers add to negative 8.
Multiply?
Multiply to the constant term, which is negative 20.
Negative 10 times 2.
Negative 10 and positive 2. Correct. So therefore, I guess we'll keep the 4. And instead of having these big brackets here now, we can write them as two binomials. They will be x minus 10, and the other one will be x plus 2. And this, of course, still equals to 0. That's great now. You factored this. Go ahead now and solve. X equals to what? From the first bracket, x equals to 10. Second bracket, x equals to negative 2. Done. Do you have to worry about the 4? Don't worry.
Why is it the opposite?
Okay, so once again, why is it the opposite? If I were to not skip steps, this is what you were supposed to do. Make x minus 10 equal to 0. And when you solve for x, you bring the negative 10 to the other side, so x equals to 10. So like what Ryan was saying, it's always the opposite sign. Okay? All right, part B. Fractions. Ew. Right? Don't like fractions, right? So what can we do with a fraction? Let's get rid of it. How do we get rid of the fraction? My suggestion is to do this, okay? Let's multiply each term by the lowest common denominator. Well, in this case, what's my lowest common denominator? Both of them have a 2, so my lowest common denominator is a 2. So let's times everything, okay? Every single term by 2 first. What's 1/2 times 2? 1, so that's 1x squared. What's 9/2 times 2?
6.
No,
No, sir.
9. Yeah, 18 divided by 2, which is 9. Good. What's 10 times 2? That's right, 20. Okay. Doesn't this look much nicer? Is it what? Times everything by 2, right? Okay, go ahead, factor this now. No? What did I do wrong? No. Oh, my answer. My question. Uh-oh. Ladies and gentlemen, yes, I made a mistake. That's a mistake in the question. Let's make this plus 10. Thank you, ladies. So let's make this plus 20. Now you can factor it.
Why is it plus?
Because if you don't make it plus, you actually can't factor this. My fault. Thank you. If I had money, I'd give you money. But I have no money. I have muffin. You want muffin?
Yeah.
You want muffin? Tea. You want tea? You want sleep? You take the whole what? The whole muffin? But you didn't give me the. You didn't find my mistake. Sorry. Okay, fine. Okay, solve this, please. We're running out of time. Solve, please. What do we get? 4 and 5. Good. Plus 4 and plus 5? Is it plus 4 and plus 5?
No, it's -5.
Oh yeah, minus 5. Just minus 5? Oh, minus 4 as well. Good. Remember, two negatives make a positive when you multiply them together. So what's our answer then? Very simply, x equals to 4. Simply over here, x equals to 5. Good. All right. And now we get to part C, the most exciting one of all so far today. Are you ready for a challenge?
No.
Too bad. You still have to try to meet the challenge. Okay, should I do this? This is my last one, okay? I'll stop after this because I think many of you are exhausted. Okay, what scares you about this one? What scares you about part C here? It's very long. What else is really ugly and scary? The brackets. Yes. So, let's make it not scary. Let me ask you to make a substitution. Let's call the bracket something else that's not so scary. What's not so scary? Huh? No, I said let's make something that's not so scary. What variable is not so scary for you guys? Fine. I'll just call it A. Okay? I would think the letter A is not scary because you want a letter grade of A, right? Anyways, make this substitution. Make A equal to 5D minus 1. Because now what happens is, instead of having this big bracket all squared, what does it become? A squared. Instead of minus 9 times the big ugly bracket, what do I have now? Minus 9A. Good. Plus 20 equals 0. Now, yes. It's still there. A squared, right?
Oh, no.
Still there. But you see how I made this nicer now? Are you comfortable with solving this?
No.
You should be, because it was the previous question. Doesn't this look like that? Yeah? Please say yes. Okay. So factor this. Two numbers that multiply to 20. We've done this already. Adding to -9, 4, and 5. So this just becomes A minus 4. A minus 5 equal to 0. Now, unfortunately, we can't leave our answer like this because we didn't start off with A. What did we actually start off with? The 5D minus 1. So now, as your last step, which is a little bit extra, I want you now to go back and what I call resubstitute. Okay? So wherever you see A, replace it with the 5D minus 1 minus 4. And then over here, it'd be 5D minus 1 minus 5. And this equals to 0. Okay? So notice I've replaced the A values with the 5D minus 1. Okay? Almost there. Almost there. No, don't clap yet. We're almost there. Let's simplify now. Can you simplify the first bracket? Well, what's -1 minus 4? -5. Good. What's -1 minus 5? -6. Good. So now you have this in factored form. Okay. You actually can factor just even a little bit more. Can someone see where I can factor out just a little bit more?
5.
The 5 from the first bracket? Yes. So if you wanted to make it even nicer, I'd say take a look at this. Factor out a 5. What's left over? D minus 1. And this would be your completed factored form, which is great. But now you're in grade 11. I don't want you just to factor. I want you to also solve. So what do we have as our answers? D equals to 1. And over here, D equals to some ugly fraction. How about 6 over 5? Ladies and gentlemen, I will stop here for today. Okay. We will continue on section 4.2, not next class, 'cause that's your test, but the class afterwards. And then we'll also figure out that interesting formula that Isabel was talking about. That will come up probably next week sometime too. Okay? All right.